All right, so I'm going to just pull up the book and then we will see what happens. So this is the version. I just found it online. It's the 11th edition. Um, I believe this is the full book. Um, yeah, so it's an older version. I don't even remember. I think I just found the PDF. So yeah, hopefully I'm not doing anything. I am not inciting activity, criminal activity, yada yada yada. They use this in school to teach people. So, disclaimer. Just trying to get the fundamentals going without like starting a whole series. Maybe this will be a series, maybe it won't. So, I'm gonna try to read through and then, worst case, link it, right? Maybe even link to the Amazon. That way, the author gets his rights if you wanna. Gets their cut if you want to buy it. Um, but to my knowledge, it's just on the way for learning. I'm not gonna read the preface. I'm gonna skip over. I'm sure all of that is very useful, but we will. Wait. Let's do table of contents. Actually, introduction is on page 23. Wait, do we want to? What is a computer? Okay, if you're on a computer, I expect you to know what is a computer. Programming language, operating systems, we can skip all that. Java, the World Wide Web and beyond. JRE, IDE, a simple Java program creating and compiling, executing a program. So kind of 1 through 1.12, it's like setup. I think we're going to do chapter 2. Like, if you don't know how to set up an IDE, look it up. Read this book, right? Get the book, right? If you the style documentation, create, compiling in Java. I mean, maybe I'll review it real quick. 33 through 47. See if I can go through, speed read it a little bit, and if not, we're gonna go straight to page 55. So that was 33, and if it doesn't work out, we're going to 55. All right, so 33. We will zoom in because I can't see that on the screen. It is a huge screen. A compiler translates the entire source code into a machine code file. The machine code file is then executed, as shown in figure 1.4b. What language does the CPU understand? What is an assembly language? What is an assembler? What is a high-level programming language? What is a source program? What is an interpreter? What is a compiler? What is the difference between an interpreted language and compiled language? So this is intermediate. Like I do like some fundamentals, but when you have learned like several programming languages or built stuff, games, whatever, you learn this to the point where, yeah. So I'm gonna try to get through some of this, but I might just skip over. Hey, we need to go to 55. So forgive me if I do that. High level source file. So area 5 times 5 times pi. Interpreter output. High level source file area. So I guess this is showing you the difference between an interpreted language and a compiler that goes to an executor. So in an interpreter, it goes straight from the high level source file to the interpreter to the output. For the compiler, it goes high level source file, compiler, gets turned to machine code, then goes through the executor phase to the output. An interpreter translates and executes a program one statement at a time. A compiler translates the entire source program into a machine language file of execution. So we can skip this. I think you know what an operating system is. See, this is World Wide Web. The book introduces Java programming and was developed by a team lead named James Gosling at Sun Microsystems. Sun Microsystems was purchased by Oracle in 2010. Okay. Bam. Okay. A simple Java program. Meat and potatoes. A simple Java program. Maybe I'll timestamp this. Where we're at. 5 minutes. 5 minutes. Chat some note real quick. Use. I'll just use this. 5 minutes. All right. It's really 6 now. But anyway, let's begin with a simple Java program that displays the message, welcome to Java, right? Hello world. On the console, the word console is an old computer term that refers to the text entry and display device of a computer. Console input means to receive input from the keyboard, and console output means to display output on the monitor. The program is giving in oops, sorry. The program is given in listing 1.1. Sorry, hit you with some slang for a second. Listing 1.1, welcome.java. So we have a public class, welcome, is how you start Java programs. We can get into the class specifications, but I'm sure that that's going to be coming up fairly quickly. We have a public static void. We have main, which is going to be the main um, part of our program. It's going to run a string with an array of no arguments. I mean, a blank, an empty string, right? And inside of the parameter for this main method is args. And this is just a part of the class. You can see where my fundamentals start breaking down, trying to explain it. It's actually this one be relatively good for me. So system.out print line welcome to Java. And then the output is going to be welcome to Java. Um, Java is well, we'll read through. I'm sure it's going to say everything. Note line, because I'm terrible at explaining this. Note line numbers are reference purposes only. They're not a part of the program, so don't type line numbers in your program. So 1, 2, 3, 4, 5, 6 are for reference purposes only. Just one moment. All right, sorry. I had to put my phone above it. Line 1 defines a class. Every Java program must have at least one class. Each class has a name. By convention, class names start with an uppercase letter. In this example, the class is welcome. So this is the class. Like I said, every program must have at least one class. Each class has a name. The name for this one is welcome. By convention, class names start with an uppercase letter. In this example, the class name is welcome. Sorry if I just repeated that twice. Line 2 defines the main method. We talked about that. This is the main method. The program is executed from the main method. A class may contain several methods. The main method is the entry point where the program begins execution. A method is a construct that contains statements. This statement displays the string welcome to Java. Right? So this is a construct. This is a statement. Inside of the construct, which is the construct in this case, in I guess all cases, is a method. This method name is main. And inside of there, the statement displays the string welcome to Java. Sorry, I gotta catch back up. Probably need a smarter thing there, or just highlight that way I can come back. On the console line 4, string is a programming term meaning a sequence of characters. A string must be enclosed in double quotation marks. So in this case, there's a string inside of this method, inside of this statement. And inside of this parentheses, we see that the string, which is technically like uh, alphabet characters, I guess, with quotation marks, and a string must be enclosed in double quotation marks. Every statement in Java ends with a semicolon, which is here. So, see, because it ends with a semicolon, this is a statement known as a statement terminator. So we have our statement terminator for this statement on line 4, which is of the line numbers. Reserved words or keywords have a specific meaning to the compiler. It cannot be used for other purposes in the program. For example, when the compiler sees the word class, it understands that the word after class is the name for the class. Other reserved words in this program are public, static, and void. I'm going to read that for you and me because I butchered it and then tried to gain the understanding. So we can see where reserved words or keywords of Java have a specific meaning to the compiler. It can not be used for other purposes in the program. For example, when the compiler sees the word class, when the compiler sees class, it understands that the word after class is the name for the class, which is welcome. Right? Other reserved words in this program are public, static, and void. So this can say public, static, or void, which are reserved words in Java, which changes the meaning of the class. Not necessarily the name, but the meaning of the class and what can be done with the class. So line 3 is a comment that documents what the program is and how it's constructed. Comments help programmers to communicate and understand the program. So line 3 is there's a commented line, and in the line it says display message welcome to Java on the console, which is describing what's going to happen when the statement runs, right? So it says they are not programming statements and thus they are ignored by your compiler. In Java, comments are preceded by 2 slashes on a line called a line comment, or enclosed between the backspace, either the backslash, the asterisk, and then the asterisk forward slash on one or several lines called a block comment or paragraph comment. When the compiler sees these 2 backslashes, it ignores all text after the backslashes on the same line. So on the same line, which is 3, once you put these 2 slashes, it turns the text afterwards into a comment, right? And when the compiler sees these 2 slashes, it ignores all the text after the slash on the same line. I read that already. When it sees the open the slash with the asterisk for the backslash, it scans for the next one and ignores any text in between. Here are examples of comments. So this application program displays welcome to Java. On this line, since this is a line comment, it'll be ignored for that line. Then we have open comment, I'm gonna say declaration for the lack of a better term. And we see we have this one, and if we can read here, it ignores any text between the two, and you have a comment, even if they're on separate lines, until your compiler finds this parenthesis, the asterisk with the forward slash, then, and forgive me, forward slash backslash. Probably should get that right one. Teach yourself. Name of blah. The symbol is commonly referred to as slash or forward slash. So this one, I did have them backwards actually. It's the one next to backspace is the back slash. The one next to shift is the forward slash. So I did have that wrong. I apologize in advance. My bad. We're learning together because I just know what it is, but I never have to speak it out loud. And apparently, I don't know what it is. We're learning together. All right, so a pair of braces in a program forms a block that groups the program's components in Java. Each block begins with an open brace. This is the open brace symbol, and it ends with a closing brace. This is the closing brace symbol. So each block is a pair of braces in the program, and that forms the block. So I'll read through the statement first, and then I'll go back to maybe we can just read this. Every class has a class block that groups the data and methods of the class. Similarly, every method has a method block that groups the statements in the method. Blocks can be nested, meaning that one block can be placed within another, as shown in the following code. So here we have public, which is a keyword of Java. It's what is the term? It's the oh crap. My bad. Reserved word, right? So we have public, which is the reserved word, class. So public class, the name of the class. Then we have the main method. It's also has a reserved word to start. Static, which is going to be the return type for this string method, or I guess this I actually don't know. Let's stick with the terminology of the book, right? So this is a class block because we have this opening brace, right? So anything after the main method, after this open brace, is part of the method block. This method block starts from this open brace to this closing brace. And every method has a method block that groups the statements in the method. Blocks can be nested, meaning one block can be placed in another. So this is the class block. This is the method block. So this one is the overall class, right? So this is a part of the welcome class, this method, and this is the method block. And maybe The reason I'm focusing on like the little in between is because it's really important. Like, because the fundamental, like when you're missing something fundamental in programming, it actually is a lot. Like the fundamental idea of it and taking your time to understand even a little tad bits is very necessary. As you see me make mistakes here, you see that it's very necessary, right? So an opening brace must be matched by a closing brace. Whenever you type an opening brace, immediately type a closing brace to prevent the missing brace error. Most Java IDEs automatically insert the closing brace for the opening brace. The Eclipse right now, it's not doing that actually. So that's something that you can change in the preferences, but I just haven't. I've been typing them all for some reason. I do not like Eclipse. Maybe I will one day, but right now I don't. So I've used it before. Anyway, caution: Java source programs are case sensitive. It would be wrong, for example, to replace main in the program with capital M main. Very important. Those are two uh, different cases. You have seen several special types, including the open and closed brace, the comment uh, declarator, for lack of a better term, and the closing semicolons, which is technically called. Sorry, I'm scrolling back through. It is. I don't want to just search for it because I think it's going to take me everywhere. Forget about it. I'm trying not to actually read through the entire thing, but I think we'll have to speed read. All right, so every statement in Java ends with a semicolon, known as the statement terminator. Right? That sounds a little tough, right? Statement terminator. Right? I forget where the camera is because I keep looking at my window with the OBS up, so I apologize. It's just a habit. Like I'm not used to just looking into the camera and talking off into the ether. So you have seen the several special characters, including the statement terminator in the program. They are used in almost every program. Table 1.2 summarizes their uses. The most common errors you will make as you learn to program will be syntax errors. They will be syntax errors. Like any programming language, Java has its own syntax, and you need it to write code that conforms. Introduction, blah blah blah. Sorry. This is the table 1.2 special characters. We have the characters that could just maybe I'll just read instead of stopping and going back and forth, back and forth. I'll read, make sure that I comprehend, and then in turn, if there's something that pops up, then I might go back. But I just might just wait for your comments. Maybe I'll just keep reading through, wait for your comments, and kind of do it like that. We'll see. So, open and closing braces, right? Denote a block to enclose the statements. We got the open and closing parentheses used with the methods. We have the open and closing brackets to denote an array that was inside the main method, which is it's kind of hard to explain, but like right, we need it to start the program. You need a method inside the program to even start, and you need a class. So I know it just said class, but like you might be able to do something with a class without a method, but it's probably at a higher level. So for now, I think you need both. So double slashes precedes a comment line, open and closing quotations, encloses a string, which is a sequence of characters, semicolon, mark the end of a statement. I forget what IE means. I think it means like you can elaborate or something. Let's see. IE, no, not Euler's ruler. Definition. Latin, which translates to, it's an IE abbreviation. In other words, in this case, that is in to say. So it's an abbreviation for in other words, sort of. In other words, sequence of characters mark the end of a statement. So the syntax rules, if your program violates a rule, for example, if the semicolon is missing, a brace is missing, a quotation mark is missing, or a word is misspelled, Java compiler will report syntax errors. Try to compile the program with these errors and see what the compiler knows. Note, you're probably wondering why the main method is defined this way and why system.out.println is used to display a message on the console. For the time being, simply accept that this is how things are done. Your questions will be fully answered in subsequent chapters because you have to build on the layers to even begin to understand like what's happening behind the hood. The program is listing 1.1 displays one message. Once you understand the program, it is easy to extend the display for more messages. For example, you can rewrite the program to display 3 messages, as shown in listing 1.2. So it's saying once you understand the program, you can extend it to display more messages. So we're going to look at this public class named welcome with 3 messages, aptly named. Public static void main with, sorry, my TV does that sometimes. Public static void main string with arguments system.out.println for this string, which is programming is fun. So open string, close string, closing this, I forgot, but you need the closing parentheses and then the statement terminator, right? Fundamentals first, and then we got problem driven. So we have the same system.println 3 times. So what this main method is going to do for this class is going to print out these 3 strings. All right. So further, you can perform mathematical computations and display the result on the console. Listing 1.3 gives you an example of evaluating 10.5 plus 2 times 3, and then dividing, putting that over 45 minus 3.5. Not sure if I said that mathematically correct. Public class compute expression. So showing us how to do math here. We still have the main, we still have the public static void main method with, just include this because I hopefully they explain that at some point, but you need it to run strings. So system dot for your main method. So system dot out dot print, and then we have this math, which I'm just going to skip over because it's the same math here. It takes it through its, computer math, which hopefully if you've learned, if not, go to Khan Academy and come back. Yeah, and then it takes it, evaluates it again, right? And then try to see did it do anything new. I guess it kind of did, but then evaluates it here, and then it prints out the uh, solution for the equation. The print method in line 3, system.print with this equation, is identical for the print line method, and the print line moves to the next beginning of the next line after displaying the string, but print does not advance to the next line when completed. The multiplication operator in Java is the asterisk. As you can see, uh, which that is confusing a little bit because when it's in the expression, right, it's multiplication, but when it's used elsewhere, it's something else. Um, but when it's in this quotation marks, that it's just something that's built in. It's actually weird that it does math on the printouts because these are technically strings. So it does something with those strings, and I would have to do some mental processing and ask some questions and probably gather that. We're probably to use AI to explain that properly, but I can't. So I'm gonna keep moving. um, is the identical? Did we read through that? We'll discuss expressions further and try to please do. What is the keyword? List some Java keywords. Is Java case sensitive? Yes. What is the case for the Java keywords? I'm not sure what it means by that question. It's lowercase for the main, I guess. What is a comment? Is the comment ignored by the compiler? Yes, it is ignored by the compiler. How do you denote a comment line and a comment paragraph? Based off if it has the um, double forward slashes or if it has the forward slash, the asterisk. I guess that's the case where the asterisk is used in a different way, right? And the comment is one of them, but it's also used in expression. And then it also can be used uh, differently. So that's confusing. It's like kind of a grammar, right? And how um, like conjugation works with like you know in the English language, or how certain phrases can mean so many different things, and one word used a little bit differently can mean something completely different in the English language. So creating, compiling, and executing. No, 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 I don't even have to read that. I guess I do. I'm sorry. We're creating, compiling, and executing a Java program. You can save a program in a file .java file and compile it into a class file. The class file is executed by the Java virtual machine. You have to create your program and compile it before it can be executed. This process is repetitive, as shown in Figure 1.6. If your program has compile errors, you have to modify the program to fix them and recompile it. If your program has runtime errors and does not produce the correct result, you have to modify the program, recompile it, and execute it again. So it goes back to what we were talking about in my first project. I had runtime errors and it did not produce the correct result. You can use any text editor or IDE to create and edit a Java source file. This section demonstrates how to create and compile and run Java programs from a command window. Sections 1.1 and 1.12 will introduce developing Java programs using NetBeans and Eclipse. From the command window, you can use a text editor such as Notepad to create a Java source code file as in 1.7. The source file must end with the extension .java and must have the same exact name as the public class. For example, the file for the source code in listing 1.1 should be named welcome.java since the public class name is welcome. So one thing I didn't talk about, since this is the 11th edition, there's newer editions and probably new introductions, and not probably, most certainly new introductions that are in Java that make all the difference in coding. So what we're learning is, oh, because even if you go to some of the um, if you go to some of the GitHubs, you'll see GitHubs from like 13 years ago, right? With probably similar project that you're working on, if not the same project. A Java compiler translates a Java source file into Java bytecode, right? So a Java compiler translates Java source code file into Java bytecode. The following command compiles welcome.java, Java, Java, welcome.java. You must install and configure the Java development kit before you can compile and run programs. See supplement 1.b. Installing and configuring uh, Java development kit 8. How to install the JDK and set up the environments to compile and run programs. If you have trouble compiling, running programs, see supplement IC compiling running Java from the command window. This supplement also explains how to use basic DOS commands and how to use Windows Notepad to create and edit files. All supplements are accessible from companion website. So I'm using my computer. I'm not really set up to like show you my uh, compiling departments. I said departments, compartments of my files. I can, however, open up Eclipse to show what it looks like, and hopefully I can just open a new program. Let's see, blah, 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 blah. Select a directory. I won't say use again. I'm going to say test workspace and select that folder and launch. And hopefully it just makes a new IDE environment. And bam, we got Eclipse. We have it open. We're going to hit File. We're going to hit New. We're going to hit New Java Project. We're going to name this Intro to Java Video. Got spaces in it. That doesn't work. Right. My bad. And I probably named that too big. Let's just put Intro 1 for the sake of this video. Now I know why they say for the sake of this video so much. So, and then we're going to open up a new class, and we're going to name it Welcome 1. I just put Welcome. I can't finish it because this, why can't I finish it? This kind of happened to me before. Package name must be used. Oh, because I don't have a lowercase letter here, it's discouraged. I'm gonna just put intro, keep it simple. Not quite sure of the specifics on the package. I mean, we just learned about the camel case, so that plays into it. But as far as the package and how it's uh, used per se, I'm still learning. So I'm guessing it's the power where it's saved on the local memory, but I digress. All right, so we're going to get back to what we were talking about and what this book was talking about. how long is this video? We're already 40 minutes in. If you made it this far, congratulations. Because I'm a terrible teacher, and I am reading through this book very harshly. And hope you like it. Right? So the source file must end with the extension .java. We already talked about that. So we're going to go to this next part. It looks like a diagram. Let's see, man. I guess we'll start from here and then go down. Looks like that's kind of how it goes. So we're going to create and modify the source code. And then that source code can be saved to the disk. The source code developed by the programmer. Public class welcome. It has that main method, and it's going to print out welcome Java. And this one kind of just stops here. There's no other arrows. And that's the source code. So another way is compile source code with Java welcome.java. If compile errors occur, it's going to go back. You're going to have to create modify the source code. It's going to run, and hopefully you can save it, right? And you're just in a loop. So that's the runtime error. If it goes through, it's stored on the disk. So this is another program. It says bytecode generated by the compiler JVM to read and interpret. It has a method of welcome with open close parentheses, 0 allo 0, and then it has another method inside of that. I'm not gonna call it class because since it's bytecode. Void main java.lang.string 0 get static number 2 3 LDC number 3 string welcome to Java invoke virtual number 4 return. So this is the bytecode. Not really similar to machine code outside of I see zeros, I see threes, but this is, I'm assuming, what it's actually stored on the disk, which is interesting. So then we're going to run that bytecode with, I'm not even going to look that up, Java welcome. As a result, we're going to see welcome to Java displayed on the console, welcome to Java. If runtime errors occur because your statement has compile errors in either one of these steps, then you're going to go back to modify the source code and start all over again. So the Java program development process consists of repeatedly creating, modifying source code, compiling, and executing programs. So this is the notepad that it decided to use to have this welcome class with this main method with this comment statement display message welcome to Java exclamation on this console with this printout, so this print line statement that says welcome to Java, so it'll say welcome to Java. So I guess we can write that out. Let's see, alright. So we have the public class welcome, luckily I named it the same, and then we're going to do public static void main, and then we're going to, we did put the close parentheses, you're going to put string array args, and then I got so hungry all of a sudden. It is too late to eat, and then we're going to put the comments. We did the open brace, then we went to the next statement, which is going to be a comment statement, right, with the 2 forward slashes. Then we're going to put welcome, caps Java on the console. Okay, and then we're going to put system dot out dot print. That autocomplete never works when I'm actually doing stuff. That's that's fine. So we're gonna put welcome to Java inside of this print statement, print line statement, and bam. The console is not there. I think you have to do window, and then it's an appearance, editor, show view, right? And then console. Bam! Now we have the console. You're gonna run this from right here, which is the bigger play button, green play button. Cannot be launched. There are no recent launches. Hit save. I can try that again. All right, and then welcome to Java. Oh my. Oh, and just for the sake of this video, I'm going to put Hello World. Hello World. This is your first program. I'm just gonna hit OK. Hello World. Welcome to Java. I think it should be reverse. We should, we should write some code that reverses. No, I'm just kidding. We're gonna keep going. So you create a Java source file using we used Eclipse to write that code, that source code. If there aren't any syntax errors, the compiler generates the bytecode file with the .class extension. Thus, the preceding command generates a file named welcome.class, as shown in Figure 1.8. The Java language is a high-level language, but Java bytecode is a low-level language. The bytecode is similar to machine instructions, but its architecture is neutral and can be run on any platform that has the Java virtual machine, which is shortened to JVM, as shown in Figure 1.8b. Rather than a physical machine, the virtual machine is a program that interprets Java bytecode. This is one of Java's primary advantages. Java bytecode can run on a variety of hardware platforms and operating systems. Java source code is compiled into Java bytecode, and Java bytecode is interpreted by the JVM. Your Java code may use the code in the Java library. The JVM executes your code along with the code in the library. Interpret bytecode. To execute a Java program is to run a program's bytecode. You can execute the bytecode on any platform with JVM, which is an interpreter. It translates the individual instructions in the bytecode into the target machine language code one at a time. Rather than the whole program as a single unit, each step is executed immediately after it's translated. I heard something weird outside, so I apologize. All right, sorry, I'm back. So sometimes, I have a family, and sometimes it sounds like there are fighting beings from another dimension, another room, but that wasn't the case. So it was just laughter. All right, so we're going to continue. If there aren't any syntax errors, the compiler generates bytecode file.class. So we already read all that. To execute Java program is to run the program's bytecode. We read that too. And we're just going to go to the diagram. Welcome to .java. The Java source code file is compiled. The Java compiler generates the welcome.class. Java bytecode is the executable file that is created and executed by the JVM. And the library code, they don't have a direct arrow, but I think we sort of get the picture. The welcome.class and the library code is executed, I'm assuming that means by the JVM, Java bytecode, Java virtual machine, any computer at all. Bam. The circle, the Acme circle. I'm telling my age here. Java source is translated into bytecode. Java bytecode can be executed by any computer with a Java virtual machine. If I get lost and I have the voice, maybe you know what I mean, and then I don't, I might have got lost in the section and maybe even needed to reread. Um, but chose not to. So the following command runs the bytecode for listing 1.1 Java welcome. Figure 1.9 shows the Java C command for compiling welcome.java. The compiler generates the welcome.class file. The file is executed using the Java command. Note, for simplicity and consistency, all source code of the class files used in this book replaced under C um, \book unless specified otherwise. So the command prompt, we got C book Java welcome file welcome.java, and then book directory, which is spelled dir here, welcome. I think that's a dot asterisk. So this is where it is on the drive. There's a serial number associated, and this is the code, the bytecode, and there's the program that's going to run if we do Java and then welcome inside of that part of the directory, and then the program runs welcome.java. So this is how it compiles down to run a Java program. The output of listing 1.1 displays welcome.java. Do not use the extension .class in the command line when executing the program. Java class name to run the program. If you use Java class name .class in the command line, the system will attempt to fetch class name .class. If you execute a class file that does not exist, a no class def founder error. A no class defined found error, I'm assuming that means, will occur. If you execute a file that does not have a main method, or you mistype the main method, e.g. by the main method instead of main, a no such method error will occur. Sorry, the way my brain works is like, oh, e.g. Yeah. In other words, by typing the main is instead of the main, a no such method will occur. We're on 40. I think the intermediate chapters are like the other program is on 53. We've already came this far. We're almost like an hour in. I think I'm gonna go a little bit further, and maybe like 7 minutes. We're gonna stop it here, because I feel like these type of videos actually needs probably more editing in the process. Uh, yeah, and I'm running off pure coffee right now and a little bit of food. So when executing a Java program, the JVM first loads the bytecode of the class to memory using a program called the class loader. If your program uses other classes, the class loader dynamically loads them just before they are needed. After a class is loaded, the JVM uses a program called the bytecode verifier to check the validity of the bytecode and ensure that the bytecode does not violate Java's security restrictions. Java enforces strict security to make sure Java class files are not tampered with and do not harm your computer. It loads it to memory first, called the class loader. If your program uses other classes, the class loader loads them just before they're needed. After the class is loaded, the JVM uses a program called bytecode. I'm reading it back for myself. Verifier to check the validity of the bytecode to ensure that the bytecode does not violate Java's security restrictions. That's pretty cool. Pedagogical note. Your instructor may require you to use packages for organization programs. For example, you may place all the programs in this chapter in a package named Chapter 1. For instructions on how to use the packages, supplement 1.f using packages to organize the classes in the text. So here's a check. What is the source file name extension, and what is the Java bytecode file name extension? Can't remember. I'm not gonna lie. I think it's .java, and I remember. I think I saw some Java C. Let's see. Uh, we're on 40. Let me see. Let me get a notebook going on here. All right. I'll just I'll just exit out and save all of this somewhere. Sorry. Let me pause the video for a second. And we are back. Wait. Sorry, I had a pop up from the notification, and we're on page 40, so I'm going to save that to have, and then we will search for the Java source file name extension because I forgot, right? My brain did not hold that information. Let's see, Java. It's actually not pulling up that, so let's take off that. I guess it's right here. My bad. So, I can't find it because there's an image. Oops. What the heck? What the heck? There we go. Alright, so it's welcome.java. So .java, right? And then generates the .class, which is executed by the JVM. So we got the welcome.java there. And then we have the welcome class that opens up and generates the .class file, which is executed by the Java command. So I'm assuming that's what it means. What are the input and output of a Java compiler? The input and output, I think it was this. Ask some good questions here. Oh, maybe I get the first references, second. I knew it was going to take me all over the world. Input devices, controlling the monitor. Operating systems perform basic tasks such as recognizing the input from the keyboard. If that's what it means. Maybe this is it because it was kind of right before 40. Let's begin with a simple Java program that displays the welcome to Java on the console. The word console is an old computer term that refers to the text entry display device. Console input means to receive an input from the keyboard. But I don't think we went over the console input. So the question is, what is the input output? The console input means to receive the input from the keyboard, and the console output means to display the output on the monitor. So I'm assuming it's just talking about this statement on 4, which is system out, which is displayed on the monitor, and if it was in, and I think it's let's just say it's another method for inputting. I just think it just worded that really weird. I can't remember screen read or streaming. I can't remember right now. It's too many terms of my brain, and we didn't review it again, so we will skip that question. Sort of. What is the command to compile? We saw it navigating the file. I won't go back to that. What is the command to run a Java program? It is the name of the class. What is a JVM? Is a Java virtual machine. Can Java run on any machine? Yes, it can. What is needed to run the Java on a computer? Uh, I guess it's the Java virtual machine. Um, Compiler generates, let me see. To execute a program is to run the program's bytecode. You can execute the bytecode on any platform with a JVM, which is the interpreter. So you need the JVM, which is an interpreter. It translates the individual instructions into the bytecode, into the target machine code, uh, into the machine language code one at a time, rather than the whole program as a single unit. And I did read that. So if a no class def error is found, you usually put two dot classes when you were searching for the file. Um, the executable class, you did an error. I guess it's maybe a syntax error technically. I don't know. If a no such method error occurs when you run a program, what is the cause of this? It's not defined, I believe. If you execute a class file that does not exist, the no class def found error will occur. If you execute a class of the file that does not have a main method, or no main method, or you mistype main, you put that capital letter, you spell it wrong, then no such method error will occur. Didn't know that about Java completely. Again, I skipped the course. Uh, anyway, I'm not even going to explain all that. We are 1 hour into this. We stopped at page 40. We are still on page 40. We're going to see after this 1.8 and reading through this if we still go. Because I want to make a second video saving our progress. Cleared out my notepad. The 1.9 programming style and documentation. Good programming style and proper documentation make a program easy to read and help programmers prevent errors. It does. Programming style deals with what programs look like. A program can compile and run properly even if written on I'm sorry. A program can compile and run properly even if written on only one line. But writing it all on one line would be bad programming style because it would be hard to read for a human. Documentation is the body of the explanatory remarks and comments pertaining to a program. Programming style and documentation are important as coding. Good programming style and appropriate documentation reduce the chance of errors and make programs easy to read. This section gives several guidelines. For more detailed guidelines, see Supplement ID Java Coding Style Guidelines on the companion website. I think it's a good idea to actually read through. I have like a bunch of these bookmarked, but I hardly read through. Not this one. Java Style Guide Cornell. This website is a website. I'm trying not to get in trouble even more. We're not gonna. This is a video in itself, actually, because like I don't see people reading through the documentation and like making videos. Maybe it's a thing. I don't know. We can read through some of it and then stop and get back to the brunt of it. Or actually, let me see. Let's finish this page first on the companion website. Appropriate comments and comment styles. Include a summary at the beginning of the program that explains what the program does, its key features, and any unique techniques it uses. In a long program, you should also include comments that introduce each major step and explain anything that's difficult to read. It's important to make sure the comments are concise so they do not crowd the program or make it difficult to read. In addition, in the line comments, beginning with the forward slashes and the block comments, beginning with the, let's just say, the comment uh, characters. Java supports comments of a special type referred to as Java.comments. Java.comments begin with the forward slash asterisk and then ends with the asterisk backslash. Actually, that's also forward slash. I apologize. They can be extracted into a HTML file and using the JDK's Java.comments command. For more information, see supplement 3 Java.comments on the companion website. Use the Java comments, just so we talked about, for commenting on an entire class or an entire method. These comments must precede the class or method header in order to be extracted into java.html file for commenting on the steps inside the method. Use that type of comment. To see an example of a java.html file, check out the liveexample.pearson.com Java doc. And then exercise 1 HTML is the corresponding code, Java code that is shown in this other Pearson deal. I'm not sure if I can open these up, because it might take you to like something else. That's what I was thinking. Yeah, so those HTML files are up. And just clicking on random HTML links will sketch in the first place. But proper indentation and spacing. A constant indentation, I can't say that word, indentation style makes programs clear and easy to read. Debug and maintain indentation is used to illustrate the structural relationships between program components or statements. Java can read the program even if all the statements are on the same long line, but humans find it easier to read and maintain code that is aligned properly. Indent each subcomponent or statement at least 2 spaces more than the construct with it is nested. A single space should be added on both sides. Sorry, I need some water. Sorry. A single space should be added on both sides of the binary operator as shown in A rather than B. So, good style is system.println 3 plus 4, this expression with the terminate statement. Then we have bad style, which is system.out println with no spaces. A single space should be added on both sides of a binary operator. It's the binary operator. So on this side, you see that the space is on in between rather than them being like this. But I actually do see this. Reading is important. Reading is fundamental. Reading. There's so much going on right now. I won't even say the slight joke that I had, the dad joke. Block styles. A block is a group of statements surrounded by braces, where there are 2 popular styles: the next line style and inline style, as shown below. This public class named test is this main statement, and it prints out this line. This is block styles, which is a next line style, which I'm assuming it means this console out print line. So this inline style, oh, actually, it's talking about the spaces. Yeah, it's talking about the actual spaces from the surrounding braces. And then this one does not have the inline styles. So I guess in the line style, which is just the open brace, then we get the main. It's a little hard to read. I guess that's the point. And then you have the open brace here, and the computer can read that just fine. But as you see, I struggle through reading where the statement begins and where the braces start for the main methods block versus the class block, because it's kind of like, yeah. I'm sure they'll explain that. The next line style aligns braces vertically and makes the program easy to read, whereas the inline style saves space and may help avoid some subtle programming errors. Both are acceptable block styles. The choice depends on the personal or organizational preference. You should use a block style consistently. Mixing styles is not recommended. This book uses the end of line style to be consistent with the Java API source code. This book uses the end of line style to be consistent with the. Oh, I did not know that. Let's look at its code. Actually, it's correct. Like it's end of line style. It's not too much. Yeah, it actually is. Look at that. That's not even something that you read through the book and like something that I noticed. Maybe other people have like caught on that fairly quickly, but maybe I'm a little slow. So um, nothing wrong with that. Reformat the following program according to the programming style documentation guidelines. Use the end of line brace. Reformat the program. I mean, it's not the end of line brace. So the name has the brace it would be put up here. There was no comment statement. It's just like right under with the open brace for the main method. And again, this next statement just right under it with the terminator and then the two close braces. Programming errors can be categorized into three types: syntax errors, runtime errors, and logic errors. Actually, that's good to phrase like that. There's three types: syntax errors, runtime errors, and logic errors. So the problem I had with my last program was not only a runtime error, but it was probably also a logic error. Come to think of it. So let's see, we're an hour and 12 minutes. It is 1:48 a.m. right now. So the coffee's working, but at the same time, I have to wake up at a certain time in the morning. So I probably got a good 12 minutes left. This video might need editing, might not need editing. I'm not sure how I'm going to run it because I did download the editing program, even though I said at the beginning of these videos that I would not, this video series that I would not be editing like that. So we'll see. But I did talk a lot. I stopped a lot. I'm sure someone's going to complain, but you're also watching this video. So it's for me to get good and hopefully us to get good as a community, right? That's the idea. Um, I have a lot of ideas. I might say that's the idea. Don't know. Syntax errors. Errors that detected by the compiler are syntax errors or compile errors. Syntax errors result from the errors in the code construction, such as mistyping a keyword, omitting some necessary punctuation, or using an opening brace without corresponding closing brace. These errors are usually easy to detect because the compiler tells you where they are and what caused them. For example, the program in listing 1.4 has a syntax error as shown in 1.0. 1.4 show the syntax errors. It has a public class named show syntax errors. In this main statement, in this main method, we have system.out println welcome to Java. 4 errors are reported. But the program actually has 2 errors. The keyword void is missing before main. I didn't even notice that. So I'm glad they said that. So but static. What is static? Is it also just a keyword? Public, static, and void. Are they all just 3 keywords, technically? in the main method. The string welcome to Java should be enclosed with a closing quotation mark in line 3. There is no quotation. I just read over that, right? Just read it out in human language, but not necessarily looking for the syntax errors in computer language. And I think because maybe that's just how the brain works, just reads through human wise and blah blah blah, spits out words, they have meanings, blah blah blah, definitions, and I understand it. I think I understand it, but I don't understand the syntax that the compiler is looking for, and that leads to these errors. Error Jordan. Dun dun dun. Since a single error will often display many lines of compiler errors, it is a good practice to fix errors from the top line and work downwards. It's a good tip. Fixing errors that occur early in the program may also fix additional errors that occur later, right? Because how the compiler works, I believe it's top down in Java. I could be lying. Correct me if I'm wrong. If not, sue me. So, don't actually sue me. I don't have any money. So, um, we have this compile, C, book, Java. This is the program that's running. Show syntax errors.java. For the bytecode, it has an error message, invalid method declaration, return the type. So I could program this out and then make it fail, and it would be useful, but I think you understand now, just based off the example that I gave earlier. Java 3 error unclosed string literal, right? So it says there's a string literal, right? And in that string literal, um, it just threw me off because it says Java 2, then Java 3, and then Java 5. And I'm assuming this is just the errors that are listed out and then kind of an array style to memory. But, right, so it expected this inside this little string, and it points right here. So right here, that's kind of funny. I guess that's what uh, I don't know what they're going for with that. I guess that's what you can do in command prompt. So Java 5 error reached the end of file while parsing. Oh, was there no? Oh, there is another one, but it doesn't show the other in embrace. If you don't know how to correct an error, compare your program closely, character by character, with similar examples in the text. In the first few weeks of this course, you will probably spend a lot of time fixing syntax errors. Soon you will be familiar with the Java syntax and quickly fix syntax errors. Runtime errors. Glad we're getting here on this video. Runtime errors are errors that cause a program to terminate abnormally. They occur while a program is running if the environment detects an operation that is impossible to carry out. Input mistakes typically cause runtime errors. An input error occurs when the program is waiting for the user to enter a value, but the user enters a value that the program cannot handle. For instance, if the program expects to read a number, but instead the user enters a string, this causes the data type errors to occur in the program. Another example of runtime errors is division by zero. This happens when the divisor is zero for the integer divisions. For instance, the program may listen in 1.5 will cause a runtime error, as shown in figure 1.1. So, I'm going to go through this and then explain a couple things, and then I think I'm going to end the video. Show runtime errors.java, public class show runtime errors. So this is the name of the class. This is the main string. This time it has the void in there, the keyword void, and then we have this printout. But the problem is it is divided by zero, and The divisor is 0 for integer divisions. I think it's anything but 0, so that's what causes the error, right? It's arithmetic exception, it said expression, by 0, um, which shows the runtime error. I think the job before is just how it displays. The runtime error causes the program to terminate abnormally. Logic errors. Uh, it's just that. That's enough. You understand. Uh, Runtime error. Logic errors occur when the program does not perform the way it was intended to. Errors of this kind occur for many different reasons. For example, suppose you write the program in listing 1.6 convert Celsius 35 degrees to a Fahrenheit degree, right? We got the class name, we have the void there. Now I'm looking for it. We have the printout with the string Celsius 35 is Fahrenheit degree, and then we have this expression inside of there, which would divide 9 by 5 times whatever this would be by 35 plus 32. Celsius is Fahrenheit degree 67. You would get Fahrenheit 67, um, which is wrong. It should be 95.0. And this division for integers is the quotient. The fractional part is truncated. I'm not going to say I'm going to explain all the math. I got to look that up. So in Java 9, divided by 5 is 1 to get the correct result. You would need to use 9.0, which results in 1.8. In general, the syntax errors are easy to find. To correct the compiler gives the indication to where the errors came from and why they were wrong. Runtime errors are not difficult to find either, since the reason and location for the errors are displayed on the console when the program aborts. Finding the logic errors, on the other hand, can be very challenging, and in the upcoming chapters, you will learn techniques of tracing programs with logic errors. Alright, we will come back at page 44. I'm going to write that down. I'm just going to put it continue for a YouTube tutorial. Page. Alright, so I saved that. So here's the thing about these errors. I ran into logic errors today. I've been doing programming almost all day today, yesterday, and all this week, really. Almost a majority of my spare time trying to get back into the swing of things after taking an extensive break. I do read databases like kind of all day, my day to day, looking for like logic related errors, but not so much looking for hardware related errors. So I read logs like all day. So I'm just saying that way it gives you the proper context of like the individual who's reading this, and then try to convey some type of understanding of Java. That being said, I'm not an expert at Java. I'm not even an expert at programming. I made some scripts, I wrote stuff, I made some games, um, websites, but like, have I made a SaaS app? Technically, kind of. Did some CRUD stuff, did some stuff with Ruby on Rails, I've done Python stuff. I've done a lot of projects over the years. I've done some kind of AI stuff from Firebase. I do fundamentally use cloud services, APIs, on my daily job. So I'm saying that because I still suck at programming, right? And I've kind of come far in tech, but um, yeah. So I can read it, right? But as you can see, having fundamental gaps in knowledge can like take away opportunities. So I think it's very important that you take the time out to that's why I'm taking the time out to actually kind of read through this. I was going to do this myself, like undocumented, um, just through the edition of the book that I'm reading, for myself, but then I decided to share it. Kind of, I thought it made sense. And then as I was reading, I did notice that I was covering over the words, probably making it harder to follow. So I'll try to watch that and up incoming videos just in case you're reading along with it and I'm not just blocking you with the cursor or playing ping pong with your eyes and attention. If you made it this far, wow, we are an hour 25 minutes in. um, Thank you. Yeah, sincerely thank you. Hopefully this is helpful. Me going through this way. Tell me if it isn't. um, yeah, but that is the video. That's part one of the introduction to, let's say, Java series for my channel. Hopefully, we get to the point where we are creating something useful, right? Because that's my intent. I want to create something useful, um, and go from there. So, Era Jordan, we are out. You see why I picked this name. I look for errors on my day to day. Maybe I'll change a bit of that. And right, I want to foster a community and work on some open source projects one day, or just contribute to projects in some useful way. So again, Aaron Jordan, peace.